So we're looking at the Math 2 second semester final. This covers chapters 7 through 12. I'm going to break them up into separate parts, and this will just be the chapter 7, which looks to be problems 1 through 8 with the multiple parts involved. So we're starting with unit 7, number 1. We have our triangle, HGF, and we have 12, 5, and 13. We need to go through and look at our true, false statements. So we'll start with sine of f. Sine of f, we're looking at the opposite over hypotenuse, because that's what sine is, and it would be 12 over 13. So opposite hypotenuse, 12 over 13. That is true. Tangent of g, tangent is opposite over adjacent, so that'd be 5 over 12. What we have here is 12 over 5, so that should actually be flipped, so that is false. Now, cosine of f equals sine of g. Cosine of f, if we look here, is adjacent over hypotenuse, so that's 5 over 13. Sine of g is opposite over hypotenuse, that's 5 over 13. So they come out equal, and that is true. So if you think of sine and cosine, if they're opposite angles, then they're equal to each other, because what's opposite to one angle will be the adjacent to the other. Now, sine of f equals cosine of f. In this case, it is false, because sine of f is 12 over 13, and cosine of f is 5 over 13, and those are not the same. If we come over here and look at E, I have hg equals 13 sine g. I'm going to write this as sine g equals hg over 13, and what I did is divide the 13 over, and that actually more fits how we typically start the trig ratios. So sine of g would be 5 over 13, or we could just say hf over 13 instead of writing the 5, and so that is false. If I look at number f, it looks like 5 squared plus 13 squared equals 12 squared. They're trying to do Pythagorean theorem here. Unfortunately, they did them incorrectly. They need to switch the 12 and the 13. So that is false. For part G, hf equals 13 cosine f. I'm going to write 13 cosine f equals hf over 13. And this is like what we did here on E. I get it to this sit-up, and now cosine of f is adjacent, the hf over the 13. This one is now true. So it's the difference between these two, part G. This one gives me a true statement. I could have used hf instead of the actual number, and it would still work. Last one we have here is cosine of g is 12 over 13. 12 over 13 adjacent over hypotenuse. That is true. For number 2, I have the two triangles are similar. And what I want to do is notice that the 4 and the 8 are corresponding parts. Since that's the case, I can double the parts here. 5 goes to 10, 3 goes to 6, and I now have the values. So sine of b is equal to sine of v. If I notice b and v are corresponding parts, their sine values are also the same. So 3 over 5 is equal to 6 over 10, so that is true. Cosine of v is 8 over 10, adjacent over hypotenuse. That is true. Tangent of t is greater than tangent of c. Now, t and c are corresponding parts. If their corresponding parts are the same, or if there are corresponding parts, their trig ratios should be the same. So this is actually false. It's equal. A little deceiving. That's not greater. It is equal. Tangent of v and tangent of b being equal. I'm not sure about that one, so I'm going to write it out. 6 over 8 is tangent of v. Tangent of b is 3 over 4. Those are equal. 6/8 reduces to 3/4. For E, I'm going to write this as sine of v equals tu over 10. Sine of v, I got tu is opposite, 10 is hypotenuse, so that is true. And then last, sine of b and cosine of c are equal. I'm going to write them out. Sine of b is 3/5. Cosine of c is 3/5. Those are both true, and I have my answer. Number 3, find the length of the side of x to the nearest tenth. So I notice here I have an angle and I have two sides. I need to first figure out which trig ratio I'm going to use, and it's going to be tangent because it's opposite and adjacent, and I don't know the hypotenuse. So my opposite is x, my adjacent is 30. Now I got to get x by itself. The way I'm going to do that is multiply the 30 over, so it's 30 times tangent 40 equals x. I go to use my calculator. Make sure you're in degree mode when we do this. And so I'm going to do 30 times tangent 40, and I get that x is approximately 25.17, but they want to the nearest tenth, so I'll do 25.2. Down here at B, I'm looking at my angle, and I have an opposite side and a hypotenuse. For opposite and hypotenuse, we're going to do sine of 53 equals x over 17. I multiply over the 17, so it's going to be 17 times sine of 53, and we get that x is about 13.57. We'll round that up to 13.6. For our next step, we're going to find the missing trig values, and it says round to the nearest 10,000th. What's that? That's going to be as 4 decimal places. So sine of 39 is 0.629, and then the 3 is going to stay because the 2 follows. Cosine of 39 is going to be 0.777, and then it's 1/4, so the 1 stays. Then we're going to do sine of 51. It's going to be 0.777, then 1/4, so the 1 stays. And cosine of 51 is 0.629, then it's 3/2, the 3 stays. Down here, when it says find the angles to the nearest whole number, since we're looking for the angle that makes it true, we're now going to use sine inverse, or sine cosine inverse. And you notice you have those buttons usually on your calculator. You can hit second or shift, or if you're using a phone, you'll hit second or shift, and it's really the ones with the little negative ones to that. So I'm going to do sine inverse of 0.3907, and when you do these, you typically want to put parentheses around them just in case it's a fraction. And I get nearest whole number here, it looks like 22.9, so we're going to call that 23. Then we'll do cosine inverse of 0.3907. Gives me 67.00, so that's 67. Sine inverse of 0.9205. We're going to make that 67. And then cosine inverse of 0.9205 gives me 23. So what do I observe here? Well, I notice that the sines and the cosine here were the same, and the sine and the cosine here were the same, as well as the sine and cosine here and there. So maybe it's when I have sine and cosine of complements of one another, because 39 and 51 add to 90, as well as 23 and 67. So when I'm looking at complements, complementary angles, so we'll say the sine and cosine of complementary angles are equal. Okay, let's look down now at sine of 47 is 0.7314. Find the measure of angle B in degrees of cosine of B. So we know cosine of B is 0.7314, so these match. So the cosine is going to be the complement. So 90 minus 47 gives us 43 degrees. So now we're looking at number 5. We need to find the value of x in the nearest whole number, and it still is the trig. So I look here, it's going to be cosine of x equals 8 over 11. Now x, I can't get it by itself here, so I'm going to have to use the inverse trig. So I'm going to make it cosine inverse of 8 over 11 equals x. So we'll do cosine inverse and make it 8 over 11, make sure it's in parentheses, hit equal, and I get that x is about 43 degrees. Nearest whole number works fine there. Come over to our other one. I have opposite and adjacent, so that's going to be tangent x equals 8 over 13. Tangent inverse of 8 over 13 equals x. So we have tangent inverse of 8 over 13. We get 31.6, so we'll call that 32 degrees. For 6a, a kite is flying at an angle of elevation of 40 degrees. Angle of elevation is the angle you're looking up, so we make that 40 degrees. We have a sag in the, we're going to ignore the sag in the string, just think of it as a straight line. We're going to find the height if 53 feet have been left out. So we set up the problem, now we've got to pick the trig ratio. It looks like sine of 40 equals x over 53. I multiply the 53 over. So now it's going to be 53 times sine of 40 degrees, and x comes out to be about 34 feet. For b, the height of a ramp is 5. The ramp will start 10 from the ground. How long must it be to the nearest meter? So I'm not looking for an angle here, so it's not a trig ratio. It's actually going to be a Pythagorean theorem where x squared equals 5 squared plus 10 squared. X squared equals 25 plus 100. X squared equals 125. So I take the square root of 125. It doesn't want it in radical form. So I'm just going to do the square root of 125. It tells me 5 root 5. The calculator's nice. It gives them simplified. But then I just hit this button here, and it gives me as a decimal. So that's going to be about 11.18. So we'll say it's about 11 feet. So now in 7a, b, c, and d, we're looking at our special right angles. In our 30, 60, 90 rule is the shortest leg's a, we call hypotenuse 2a, and that longer leg will be a root 3. And for our 45, 45, 90, our legs are the same and our hypotenuse is a root 2. So we look at our first one, a. We have it's 30, 60, 90, so 60 there. I double the 10 to get to x, so that's 20. I multiply by root 3 to get to y, so that's 10 root 3. For b, I know the legs are the same because it's 45, 45, it's isosceles, so w is 5. And then v, I'm multiplying by root 2 because I want to make it bigger. Multiply by root 2 and make it 5 root 2. For c, we have these are the same, so that is a 45, 45, 90. I have the 14. I'm not going to multiply by root 2. I'm going to divide by root 2 because I actually want to make it smaller. So that's going to be 14 divided by root 2. I'm going to simplify it by making it 14 root 2 over 2, and it becomes 7 root 2, and that is both of them. For d, I have 9 is the longer leg, so I have to divide by root 3. So I'm going to simplify here. I get 9 root 3 over 3, which gives me 3 root 3, which is t. And then I'm going to double that, multiply it by 2 to get to u, so that's 6 root 3 as my answer. Last one of this set, we're looking at is the triangle right, acute, or obtuse, and this is where we use our Pythagorean theorem, and we're going to set it up and look at the longer leg and how it compares. So 15 squared equals 9 squared plus 12 squared. I get 225 equals 81 plus 144. If I add the right-hand side, I get 225 for both. So since it's equal, I'm going to say it is a right triangle. Now we come over here and we have 41 squared equals 40 squared plus 10 squared. And I like to write the longest side first when I do these. 41 squared is 1681. 40 squared is 1600. Plus 100, we have 1700. And 1681. Clearly not the same. It opens bigger to the 1700, so that means that 1700 is bigger, so that means our other sides are bigger, this one's too small, and if we think about our right triangle, it had to close down, and if it closes down like that, it's less than, it's going to be acute. So anytime the longest side is less than, longer leg is less than, you're going to say it is acute. This last one's a little bit tricky because we have to make sure we pick the longest side correctly. If we kind of approximate, the square root of 101 is a little bit bigger than 10, and we know that it's smaller than 11 because 11 is the square root of 121. So we're going to go 11 squared equals 4 squared plus the square root of 101 squared. I get 121 equals 16. This just becomes 101. So I got 121 and 117. Well, obviously the 121's bigger. If it's bigger, then that means our right angle is actually opened up. So it's going to be an obtuse triangle. So we have right, acute, and obtuse.